Welcome to the last part of the Intel 4004 CPU. For easy understanding, it would be better that you watched the other two parts, but it is not necessary. In this video I will explain the remaining jump commands. We have already seen the unconditional jump, JUN, and the increment and skip if zero jump. Increment skip if zero jump. Now I'm going to explain the jump to subroutine, and the indirect jump, GIN, and the jump on condition. Okay. I am starting with the jump to subroutine, JMS. In the CPU, the 4004 is not different to other CPUs. The return address is put on the stack pointer, but the stack pointer is not referring to a memory location, but it is integrated in the CPU, with the drawback that it is only 3 levels deep. Here you have the level 1, level 2 and level 3. This is the stack pointer. That means you can nest only 3 subroutines. Let's give it a try. We're doing a jump to subroutine. Let's label it S1. I will put an operation here. Here's the label S1 subroutine. I will do a second jump to subroutine, S2. And for the return, it's not return, but it's called branch back load accumulator, BBL. And here you have to specify a value for the accumulator. I will choose one for subroutine 1. Then I will create a second label for subroutine, and here jump subroutine S3, branch back. Let's take 2 for second subroutine, and third subroutine, branch back label 3. Generating the code. So let's put the code into the ROM. Here we have the first command, jump to subroutine to address 3. Let's disassemble. 0, 1, 2, 3. That's subroutine, the first subroutine. Let's step through the commands. He has put the program counter on the stack and jumped to subroutine, the first subroutine. The next command is jump to the second subroutine. Let's step. And he has put the program counter again on the stack. Let's jump to the third subroutine and put the program counter again on the stack. The branch back load accumulator 3 will return from the subroutine and is putting this value into the accumulator. Step. The return value is put into the accumulator and has retrieved the program counter from the stack. branch back from second subroutine. 2 is now in the accumulator. And return from the last subroutine. 1 in the accumulator. The stack pointer is empty again, and we arrived at no operation command. After returning from a subroutine, you will lose the former value of the accumulator. Maybe let's give an example. The accumulator would be FF, and we have to save the value of the accumulator. You could do it and write it to memory destination, or you can put it in a register. There's a command exchange. I think it's XCH. Let me try. And specify the register. Let's take register 1. So we'll exchange the value in register 1 with the value in the accumulator, and the accumulator will put it in register 1. After the jump to subroutine, we can do the exchange again, and we'll restore the original accumulator value. Generate code, switch back, resetting everything, and let's step through the program. Accumulate is F, and we do an exchange with register 1. So we have saved or exchanged the value of the accumulator and put it into register 1, and in register 1 had the value 0 before, so let's put 0 in accumulator. Step to the program, returning from the lab subroutine and exchanging the accumulator again, and we have F back in the accumulator. The next command is the indirect jump. Indirect jump, and here you specify a register pair. Let's take the second one. We have to specify the value of the register pair. Fetch immediate. The second one, and we're putting the address of label 2. And we're using another register pair. Let's take 1P for label 1. Is jumping to label 1. Label 2. Label 1 is here. Let's do an operation. And label 2, we're jumping to label 1. Resetting everything, loading, putting on the second pair register the value of label, the address of label 2, 0, 1, 2, 0, 1 for the first label. Now it's jumping to label 2, and there is jumping back to label 1. Again, the operation command. The last jump is the jump on condition. JCN. The forward slash is a command. You have to specify the condition. The condition is a 4-bit value. The most significant bit is the inverted. The next one is the accumulator is 0 condition. The next one, carry, is set condition, and the last one is the test flag is set condition. So if you want to jump if the accumulator is 0, you would specify this one, this bit. If you want to jump if the carry flag is set, you would put on the one here. If you want to jump if the carry flag is not set, you would invert it, invert the condition. If you want to jump if the carry is not set and the test flag is not set, you would also put a 1 here. Let's do an example. Load the accumulator with the value of 8. Rotating the accumulator to the right, and we are actually rotating the accumulator until the carry flag is set. So jump on carry is not set. It's 2 and 8 is 10. $A hexadecimal, and jump on, let's say, call it loop 1. Loop A, loop 1. Let's give it a try. I'm resetting everything. Loading the commands. Stepping, accumulator is 8. Rotate accumulator, the value is 4. Carry is not set. Jump. 2, 1, and 0. And now the carry flag is set, so you won't jump and take in the next command, which is an operation. Let's do a visual effect with the output ports here of the RAM chip. I have to specify the bank 0. So clear both means clearing the accumulator and the carry flag. Designate command line for the bank switch. Specifying the chip selection. Let's do a send register control 0p, and here we're writing the memory port. Resetting, loading, step, writing memory port, run, and it's done. Let's go really crazy and add the chip 1 and the ROM output ports in the code. Okay, let's specify the second chip. Register pair 1 and second chip 4.0. And here we're loading the accumulator. We have to do a write memory port to clear the output port of chip 0. Loading the accumulator with the value 8 again, clearing the carry flag and copying the code. Sorry. So loop 2, write memory port, and loop 2, generating the code. Wait, I forgot to choose chip. Second chip. Send register control 1P. Generating code again. Reset, load, and stepping through the code. And works fine. Okay. Let's add the ROM port. w.o.p.r and it's write ROM port. Okay, I have loop 3 and just put an endless loop here. Stop, unconditional jump on stop. Generating code. Oh, forgot to copy the code. Pasting, load, and animate. Oh, this was too fast. Let's put a pause in there. Let's call subroutine wait and label wait. Increment skip on 0. Let's take register 4. Loop wait and return from the subroutine. Now we have to call the subroutine. Let's put it in here. Save on the accumulator. Let's take register 15. Jump subroutine. Wait. Exchange the accumulator. Copying the code. Put it in here and in here. Let's do a test run. modifying the code. Set, load and animate. That's a little better, but still too fast. Let's put again a loop in here and another one. L2 and LW3. Generate code. Pasting it and animate. Yeah, now it's better. I will add now a jump condition for the test flag. Here at the beginning of the program. Let's say test flag 0, a label, jump on condition, binary format, inverted, here's the accumulator, carry flag and test flag. It will jump to test flag 0 as long as test flag is 0. Let's go to the endless loop and replace it with test flag 1, jump on condition, so it will jump to test flag 1 as long as the test flag is 1. And we invert the output ports. Write ROM and to loop the number 4. Loop 4. No, this is wrong. Remote accumulator left. Right, ROM port. Saving the accumulator, jumping to the RAID procedure, restoring the accumulator. Let's do again a remote accumulator left and jump on condition 10, loop 4. Okay, yeah. Alright. Read ROM to clear the output ports. Loading the accumulator with value 1. Clearing the carry flag. And switching to bank, to chip 1. Doing another loop, 4, 5. Write memory port. The RAID procedure, restoring the accumulator, rotate accumulator left, jump on condition 10 to loop 5, and the last one, write memory port, switching or selecting chip 0. Loading value 1. Okay, clearing carry flag. Level 6. Right, memory board. Jump subroutine. Wait. Restoring the accumulator. And mode accumulator left. Jump on condition 10 to loop 6. And we're clearing the carry flag and jumping to the begin, TF0. I hope I didn't make a mistake. Let's test it. Reset, load, animate. Yeah, it's waiting for the test flag. Nothing is happening. The test flag is directly connected to the test input pin of the CPU. Change it to test 1. And it works. And now it waits until the test flag is unset again. Yep, works fine. And waits again for test flag. And back. Yeah, works perfectly. Well, that's the end of the last video part of the Intel 4004 CPU. Thank you for watching. I hope you enjoyed the video. Bye bye.